Hello and welcome to this tutorial on how to get going with the Intel Edison board with the Arduino breakout board. I'm going to show you how to get the board up and running, how to erase it so you have a clean system with the latest firmware, and then how to connect it to the IBM IoT Foundation Cloud. So let's get started and have a look at the board. So here we have the board. You can see that I've already attached the Edison module, which is this module here, to the main breakout board. One thing to be aware of, this little switch here, make sure it's towards the small micro USB port, not towards the large USB port in the power socket. So this switch needs to be in the down position as shown here. To power the board, you've got a number of options. You can provide a 12 volt power supply here, or you can connect this port to your computer USB port or a powered USB hub. One thing to ensure is that your laptop USB ports provide sufficient power. So I tend to use a powered USB hub or the 12 volt adapter. So here we are in a fairly recent install of X Yosemite 10.10.5, and what we're going to do now is install the required software for the Intel Edison board. So the first thing we need to do is install a Java virtual machine. If you don't have a Java virtual machine, you'll get a warning when you install the Intel software. So we need a Java JDK, and we want the Java version 8 development kit. So accept the license, and then we download the Mac 64-bit version. And then the next thing we want to download is the Intel software. So Intel Edison IoT gets you there. And we want the Intel Edison developer zone. So it's software.intel.com en-us IoT hardware Edison. And this is the site. So we're going to follow the Get Started guide. So hopefully you've assembled your board. If not, the instructions are here to attach the Edison module to the board. And then next we choose OS X as our operating system. And then we get access to the download. And that's now going to download. So while we're waiting for that, let's go and install Java. And then if we right click the Intel and we just want to open it with the archive utility, you can double click it, it'll do the same thing. And then it'll expand out that tar file. And that'll give you the application. So to launch that, we just double click. So this shows you what will be installed. and it will also update the firmware image. So now we've got to connect the Edison to the computer. To connect the board, you connect the power first and then the USB ports, and we will use both of the ports during this exercise. I've done this step a number of times and I always get this warning, so don't worry if you see this warning as well, because what we're going to do now is go through the process of how to install a new image without having to go through the installer again. So if I jump back into the zone here and go to the download section, you'll see that you have the latest image here, and what you want is the complete image. So I'm just going to select that to download that image. Then the next thing we need to do is actually log on to the Edison board. So to do that, you need to open a terminal window, and if you're not sure where that is in OS X, it's in the utility screen, or you can go into your menu, select Spotlight and type terminal. So Mac has a built-in terminal and it is the screen command. So we're going to say screen, we want to see log the output to the terminal, and then the device is tty dot, then if you hit U and a tab, it should autocomplete. So you can see I've got a USB modem and a USB serial. So these are the two Edison ports, and what I actually want is the CU USB serial. So TTY and CU are effectively the same port, and the Intel instructions ask us to use the CU. So it's screen minus L / dev / cu dot USB serial, and then you'll have a different identifier here which would be unique to your Edison board. And then we need to give it the speed, which is set to 115/200. So that's the command you need to type: screen minus capital L / dev / cu dot US serial dash, and then your board will be unique, and then 115/200. When you hit enter, the screen command will start. If you hit enter again, you should get the log on. So by default, the board has no root password. So if you've got a brand new board and you type root here, you'll get logged straight in. I've used this board before and I've set a password, so I need to enter the correct password, and then you're logged on. So this is a Unix distribution, and when you reflash the image, if I look at the file systems, the home file system does not get erased. So everything else on the board will be erased, but the home file system will not be erased. So if you want to reset a board to effectively the factory state, you have to manually clear out the home file system. So by default, you'll be in the home root directory. If you come up one level and do an ls, I've only got the root user installed, so I've only got the root user directory. So if I come into the root directory, you'll see that I have some content already. So to remove that, rm space minus rf space star, and then rm minus rf space dot star dot asterisk. You'll get those two warnings. So now if I look, I cleared out that directory and all of the subdirectories. So I've now cleared out the home directory, and we can now flash the main image. So the first thing we need to do is, if we open up disk utility, so again that's in the utilities folder and the disk utility, what you should see is a Linux file CD gadget media device, and it'll have one partition. What we need to do is we need to clear out that partition. So select the disk, select arrays, you want an ms.fat format, and then you can just give it a name. So it's easy to identify. I always call mine Edison, and then just hit erase. That has now cleared out that file system. So if I go look at it, I now have an empty file system. I'm just going to bring up a second screen so we can close off the disk utility. And then if I go to my downloads, and I can see the image. Now by default, when you download an archive, it will automatically be expanded. If you still have a zip file, double click it and that will expand the image for you. So you need the folder that we downloaded, which is the full Edison image. And if we go into that directory, all we need to do is copy all of the files. So select all of the files and then just drag them onto the Edison drive. So when all the files have been copied, you can eject the Edison disk. Back into the Edison, I simply type reboot space OTA. So that's reboot OTA. And this is going to reboot the system, and then it's going to reflash the entire file system other than the home directory with the new image that we've just transferred to that local Edison disk. So you can see now that it's actually reflashing the disk. We're not doing a normal Linux kernel boot. We are actually flashing the new image onto the Edison. So that's reflash complete. and we're now doing a normal Linux startup. So here we are. We've now got the logon prompt. So again, enter root, and this time we go straight in. We've done a reflash of the system, so we're now at the initial state of the operating system. So I just type root and go in without a password. And then we're going to use the configure Edison command to actually set up the board. So it's configure underbar Edison. There we go. If I just type that without any parameters, you'll see that it shows us all of the different options. So I can go in and just set up the Wi-Fi, or I can set up a password for root, or the name of the actual device. But what I'm going to use the setup option, because that's going to take me through these first three. If I ever want to find out what the IP address of my board is on the Wi-Fi interface, I can use the configure Edison with the show Wi-Fi IP. I can find out what the current version of the firmware is using version. So we're just going to say configure Edison, and we're going to do -- setup. And then it's going to ask me what the password. This isn't going to be the root password from now on. And then it's a good idea to give Edison a name, especially if you're going to use it in a hack where there's going to be multiple boards, because a number of the Intel tools do network discovery. So if all of the boards don't have unique names, it's very difficult to work out which one is yours. So I use my initials and then just Edison. And we're now going to set up the Wi-Fi. So you'll see we've now got an IP address assigned, and what we can do just to verify that is if we open up a browser and if we go to HTTP then you should see this screen showing that your board with the host name you assigned and the IP address that's been assigned. So that shows that our Edison is on the network. So the next thing we're going to do is we're going to install NodeRED. Again, in a browser, if I go to NodeRED, which is NodeRED.org, you'll see that you've got the instructions here, full documentation, but it advises to set up on a Linux or OS X, you just simply run the install with the global option. However, on an Edison board, if we look at the file systems, you'll see that the home directory has the most space. If you do a -G, it would be installed in this partition, the root partition. So I just want to use this space here. So I'm not going to do an install -G, I'm just going to do the install into my local home directory. So we're in the home directory, I go npm install. Now I'm going to put a parameter here which is unsafe perm. And what this does, it'll just stop any warnings that you're installing as root. We're using the default root user on the Edison board, and a lot of packages complain if you install as a root user. So putting this on will just remove those warnings. So if there is an issue when you do the install, you won't have a lot of clutter in the log about installing as root. And then we're simply going to install NodeRED. That's NodeRED installed now. But one of the issues when you install it as a local install rather than a global install is that any commands don't get added to the path automatically. So if I type NodeRED, command not found, it hasn't been added to the path. So I'm going to do that now. I just change into the user bin directory. And then we're just going to create the links. So I've created the two links for the NodeRED command, and there's also a NodeRED Pi in the NodeRED bin directory that I've also linked in there. So that means I can now run NodeRED from wherever I am in the file system. So just return to my root directory, my home directory, and then I can run NodeRED. And when I start NodeRED on the Edison board, I want to tell the node runtime that this is a limited resource board. So I want to pass a parameter in to tell it to use memory more efficiently. So that is max old space size, and we go to size of 128. So here we are, we've got NodeRED running, and it tells you that it's actually running on port 1880. So again, I can go to a browser and I can go to the IP address of the Edison board at port 1880, and this is my NodeRED running from the Edison. So NodeRED is a graphical environment. You've got a palette of nodes down here, and to create a program or a flow, as it's called in NodeRED, you simply drag a node from the palette onto your current sheet. So I've created an inject, and then if we just pull a debug node, to connect nodes, you hover over one of the connections, click, and then drag to the other node and release. So that's now created two nodes and joined them. And to run a program, you simply deploy it. So what an inject node does is it simply starts the flow when I click the button here. And depending on how I've configured it, it will either give me a timestamp, or I can set it to do a string, or just pass a blank message down the connection. And the debug node will simply output the content into the debug window and optionally onto the console. So clicking here, I get the timestamp, which is the number of milliseconds since 1st of January 1970. So here we go, we can just run that flow. So that's just running NodeRED. To stop the program, I hold the control down and hit the C, Control C to stop the application. But what I want to do now is make sure that NodeRED is running whenever I start up the Edison. So that environment is always there when I start up the Edison. And to do this, I'm going to use a module called PM2, and that will manage the NodeRED runtime. So that's a node package. So to install it, npm install, and I am going to put this globally. Again, we're going to put the unsafe perm option on, and it's simply called PM2. There we go, we have PM2 installed. So to start NodeRED, I'm now going to type PM2 start. I now type the path to the command. And then I'm going to pass in the arguments about the memory. So we do that with node args equal, and then I'm just going to pass in the commands I want to pass, or the arguments I want to pass to the node runtime, which is max old space size equals 128. If I wanted to pass any arguments into the node application itself, such as the -v to turn on verbose debugging, I can do that by putting double dash, and then any arguments I now put on the command line will get passed to the node application, such as the -v. But I don't actually want to put any additional parameters into the node application. So I simply type enter, and that will tell PM2 to start NodeRED. So there we have NodeRED running, and we can check that out. Again, bring up the browser, and if I just refresh that, we can now see that NodeRED is actually running into the debug tab, and then I can just run my flow again, and that's running fine. So there we have NodeRED running. I can look at the status of a PM2 process by doing PM2 list, or I can use a shortcut which is just L, and that will list the current state of applications running and managed by PM2. And I can also look at the logs from an application, so PM2 logs, and I just give the app name here, which is NodeRED. And this is going to tail the console log. So as I'm running NodeRED, the console will keep coming out on this screen until I press Control and then C to stop that. So I can see what's running, and I can get the logs. So now what we're going to do is we're going to get PM2 to start up with the system boot. And before I type the command in, I need to go and create a directory. So that's mkdir. I need to make the directory /etc/init.d. So make directory /etc/init.d. And once you've done that, we do PM2 save. And that will save the current state of PM2. So anything that's running now will be started automatically when the system starts, and then PM2 start up to get it to run at system start. And that's all there is to it. Just a couple of other commands while we're here. So I can do PM2 restart to restart a process. And sorry, PM2 restart to restart a process. I can do PM2 stop to stop a process, and I can do PM2 start to start a process. So what we're going to do is reboot the system and just check that all that is working. So here we are rebooted. We log on with the root user. And this time you'll notice we've been asked for a password. And if I do PM2L for the list, you'll see that we've actually started up NodeRED environment. Just to test that out, if I go and refresh the browser, switch back into the debug tab, and there we go, we're running our flows after the restart. So the last thing we're going to do is connect this NodeRED environment up to the IBM cloud, to the Internet of Things Foundation cloud, which can then flow into IBM Bluemix. So it's very easy to install new nodes. We just need to go into the node modules and then NodeRED directory, and we can install nodes here. And if you go into npm.js.com, this is where the npm command pulls all the packages from. And then we just type NodeRED. You'll see that we have quite a lot of nodes that we can install. But the one we want is the one to connect to the IBM Internet of Things cloud. So it's npm install, and it's node-red-contrib-scx.ibm IoT app. So it's node-red-contrib-scx-ibm IoT app. So that's just installed, and then I'd simply do pm2 restart NodeRED to load that node into the environment. And now if we go back into the NodeRED environment, we'll refresh the browser. And this time you'll notice that we've got an additional node here, which is the IBM IoT in. So that's how we can pull data from the cloud. And then further down, we've got the IBM IoT out node, which is how we send data to the cloud. So to test that out, I'm just going to drag that onto my space here. To edit a node, I simply double click it, and that'll open up the editor panel. And then this is the edit sheet for the IBM IoT. There are a number of ways we can run this. One is using an authentication, a set of keys that I can authenticate to a service. But for this exercise, we're just going to use the quick start node. So I then need to enter the device ID. For a device ID, we typically enter the MAC address of the device. So if I do ifconfig, and we're going to get the MAC address of MAC address of the wireless LAN card. So I do Control C to copy that, or Command C to copy that, and then Command V to paste it. And we can't use a colon, so we just need to delete the colons out of that MAC address. And that's our device ID. For an event type, we could just use, as they recommend, status. Data, we're going to get values in from the previous node, and then we can give it a name. We're just going to say app out, and that's the name that appears here. We connect it. I'm just going to put values in there, and then you'll notice that the warning goes. And the data we want to send, we're going to create in the input node. So I want to send a string along, and I'm going to input a JSON document to send along. So the JSON document has a certain format for the IoT cloud. So the first thing we need to do is say we're sending device data, and that device data is itself a JSON object, and then I'm just going to send one value. The key is A, and let's put the value as 1. So that's our JSON document that we're going to send. And we just say OK. So if I now deploy that, and then inject that, you'll see we're now sending this data. And to test that, if I open up another tab and go to the quick start, that's the page there, quickstart.internetofthings.ibmcloud.com. And I just need to paste in that MAC address again, but again, remove the colons, and then say go. And that's now, this quick start application running on the cloud is now listening for device data. So if I go back to my flow and hit that inject again, and then jump back to the Internet of Things Foundation cloud, it is now found the data. We've got our data point from A, and if I just come down here, you'll see the value is 1. And just to prove that's live, if we come back into this node and change that 1 to, say, a 5, we have to remember to deploy the application again, or deploy the flow, and then hit the inject. So we've now sent 5, come back in here, and you'll see the value has automatically updated to 5. And once again, just to do that, double click in, let's change the value now to 2, say OK, deploy the flow, and then inject to deliver that message. We've sent the 2, and on the cloud, again, the value is now changed to 2. And that concludes this video.